So they can ask the experts a lot of questions and have a chat with them about this project or another project. So one of the good things that ProjectPro actually tries to pay attention to is what you mentioned, reusability and ease of use.
Hello everyone. Welcome to yet another expert session of ProjectPro. Today we have with us our expert, Muhy Eddin Za'ter. Muhy joins us today from United States of America, and it's a pleasure to have you on call today, Muhy. Why don't you introduce yourself to our viewers?
Okay, thank you for the introduction. I'm Muhy Eddin Za'ter, originally from Jordan, currently pursuing a master's degree in electrical engineering at University of Colorado Boulder. I had 4 years of experience working as both machine learning engineer and data scientist at Samsung R&D and another Jordanian startup, Mawdu.com. I worked really heavily on natural language processing and speech processing. And I'm trying right now to study electrical engineering because this was my bachelor background, and I'm trying to mix it up with the artificial intelligence. So maybe we could come up with the new applications to do artificial intelligence in the field of energy.
So you come from a background of electrical engineering. You have pursued your bachelor's in that. You're doing your master's also in electrical engineering. And you have a passion for machine learning. You have 4 years of experience in it. So you are pursuing electrical engineering because you want to incorporate machine learning concepts into the field of electrical engineering, and you see the future there?
Yes, certainly. When I look at machine learning or deep learning in particular, I think of basically a universal, or mathematically speaking, they are called universal approximators. So basically you could do a lot of, basically it can map any output to any input given the right data. So in mathematically speaking, a deep learning or machine learning model can actually imitate any or approximate any function. So for example, machine translation per se, it's basically a function between the input language and the output language, or the target language. But we as humans, it's almost impossible for us to come up with the equation that actually converts from the German to the English language, for example. But machine learning or deep learning can actually approximate this equation. So that's how powerful deep learning actually is. And in electrical engineering in general, there are a lot of problems that needs to be mapped. Our current computers or current computation power really does not allow to have fast and efficient simulations or approximations or detections for heavy electrical engineering applications. So machine learning and deep learning are a perfect substitute or alternative for these kind of applications.
I see. Yeah, that makes sense. That makes sense. So, my next question to you would be now, you are a student, and I'm sure you come across many projects which are basically a practical approach to learning anything. So what is your philosophy on the practical approach to learning?
Make as many mistakes as you want, as you can, as fast as you can. That's my approach. Just dig in the code, try to make as much as mistakes, because that's the only way you actually learn.
Yeah, that makes sense. Make as many mistakes as early into your career, the better you will be later on.
Yeah, it seems apply on learning coding, learning a specific project. That applies to all.
Yeah, that makes sense. That makes sense. Yeah. While you are replicating a machine learning model or a deep learning model, which part of a development cycle you find the most challenging generally?
So this might be a controversial opinion somehow. So my opinion is, when implementing something machine learning based or deep learning based, the first thing or the most challenging part is actually the data acquisition and choosing the correct data, and to define the problem properly and in an effective way. So if I give you an example, in 1997, Intel programmed using artificial intelligence a computer that was able to beat Gary Kasparov at 97, sorry, which at that time he was the most brilliant chess player ever. And AI at that time was able to beat that a human being. Although, and quite recently, we are seeing Boston Dynamics posting some videos for robots that can actually open a doorknob. And this is kind of counterintuitive when we think about it. Like, we never call a human very intelligent because he or she can open a doorknob. On the other hand, we can really, chess is a very good measure or indication of intelligence somehow. Another example would be self-driving cars. We are still struggling. Researchers are still struggling to enable self-driving cars. But on the other hand, very complicated tasks like learning chess was achieved in 1997. And this is primarily because chess is a better defined and easier defined problems for computers. So to actually achieve good performance for any machine learning or deep learning or artificial intelligence model, you have to have a proper definition for the problem, good feature extraction techniques, and the best data acquisition you can have.
Yeah, makes sense. I mean, and while you said that it could be controversial, but that is the most challenging part that you find. So that's that's good to go. And Muhy, now that you've been associated with ProjectPro for some time, one key part of our product is the reusability of projects. Now, who do you think can reuse a project, and how much time something like this could save? Let's say the projects you have built for ProjectPro, who do you think can reuse, and how much time can a project like this save somebody's time?
One of the project the project I've worked on was speech processing or speech recognition, and this the architecture for this network is kind of complicated and new. So I believe writing the code would be a headache. So as per ProjectPro policy, when they asked me to write the code, they asked me to make it as much as reusable as possible and as much as friendly, user friendly as possible. So these two parameters were taken into consideration. So for example, you could train your network, train your whole project on your own customized data without writing a single line of code. Only just dealing with a configuration file from a simple interface. On the other hand, it is refactored and written to be if any user wants an extra feature of this speech or an extra small step like pre-processing that was not accounted for from our account, it's very easy. It's very easy to add this feature. So that's what makes the reusability. It's not gonna take a lot of time coding anything. It might take nothing to code, just to have your data according to the format that was indicated, and that should be it.
Yeah, that makes sense. And my next two questions that I have for you actually comes from our customers, and this one of these questions, the first one that I'll ask you, I ask every expert who interviews with us. Now, our customers generally ask us, see, I need only 2-3 projects. Your platform provides 250 projects. So why you as an expert, you think a user needs 250 projects and not just 2 or 3?
That's a good question. Okay, so many answers I can think of. So first of all, data science, machine learning, or deep learning is like the jobs in these fields are 90% application. You utilize machine learning or utilize deep learning for some specific application, and the other minority is to actually try to enhance or improve some kind of an existing network or come up with an existing network. And this is a very heavily mathematical task. And usually PhD holders or PhD students does this kind of job. So which leaves us with the other part of machine learning or artificial intelligence jobs, which is actually application based. So you're going to use some existing networks that we all know about, that all of the literature knows about. Maybe in a different way you can use it, but you'll use the existing technologies to solve a lot of problems. So for example, let's say you're starting with speech recognition. Probably you're gonna solve that in a year. Then will come up a new project. And as we mentioned earlier, since deep learning behaves as universal approximators, it can solve a lot of problems. So you can have it at the same company for, let's say you have a bank as a customer or a client. So they have a lot of things that machine learning can do or data science can do. For example, their chatbots, which consists of at least 5 different AI projects. Then they have like some kind of forecasting for their projections for like next year or the year after revenue. They have some detection techniques or fault detection techniques, fraud detection techniques. They have also as well a lot of analytics when it comes to time series data that also uses machine learning. So that's only on one client. So usually that's one answer to the topic, to the question. The other answer would be because in order to really grasp the power and the strength of machine learning and deep learning, you really have to see it act in different function layers. So for example, you're gonna need machine learning as an optimizer. So you have to learn how it works as an optimizer, sometimes as a classifier. So you need to see some projects that use a classifier. Also, different project requirements gives you an insights, a lot of things. So for example, let's say if we have a machine learning for, we need an artificial intelligence system for detecting some kind of a disease. The evaluation metrics or what takes into mind when evaluating this kind of artificial intelligence model is far different from evaluating a speech processing technology. So it's much better for you to be well-rounded with the projects, and it's gonna do be very beneficial for you.
Yeah. So basically, correct me if I am wrong, one particular project or one particular concept may have several applications, and each one of those application is a project in itself. So exactly. Let's say you've just done 2 or 3 projects, you probably just know from one concept, you probably just know 2 or 3 applications. But the more number of projects that you do, you understand more applications, and similarly concepts also, because there's so many concepts, there's so many techniques there.
Yeah.
Yeah. Okay. Next one again comes from our customers only. They want to know from our experts, particularly about how your projects can help them get a job. And also how can they highlight your project in their CV or portfolio to, let their CV shine through?
Okay, that's a nice question. So, for example, one of the things that ProjectPro actually tries to pay attention to is what you mentioned, reusability and ease of use. So, for example, let's take speech recognition as an example again. You might, so since you don't have a lot of burden on coding right now with using ProjectPro, you can have run very quickly a lot of networks and a lot of models on different data, and come up with your own study about speech processing, let's say for the English language, let's say on Indian accent. So you train some model, you train a lot of data, you try to figure out some things, like if I added 50 hours to the data, what happens to the performance? If I added 100 hours of data, what happens to the performance? If I tweak this hyperparameter tune, this hyperparameter, what would happen? You could come up with your own study, and you will have a lot of insights about that. And you could maybe use that to write your own report or your own article or maybe a paper. That's one thing. Also, it's heavy coded, and so you could try to users could try to make sense of the coding and maybe learn a little bit coding or how to actually implement a project that be reusable for everyone. And basically, so they can ask the experts a lot of questions and have a chat with them about this project or another project. So
yeah. Okay, now let's talk about you when you interview for any particular role. What are the few key things that you look for in a candidate?
Okay, we have interviewed a lot of people before, so I personally prefer soft skills much more than technical skills. So so for example, sometimes when I go when I interview someone and ask them some questions, I try to make the question harder at each level, just to see when they hit a bump, how they'll act. So so for example, will the candidate try to ask people around him, ask the interviewer, tries to interact with other people to see their opinion as well, or just maybe just try trying the same approach as before when he or she was hitting the bump in the question or something. So this kind of qualities we look at. We look at how your attitude of learning. So because we're basically in a very fast-paced field. Tomorrow is not going to be the same as yesterday probably. So we have to be fast learners.
Yeah.
So, and to be fast learners, you have to be really passionate about the field. These are some qualities we kind of look for. And one technical skill is coding, definitely, because if you do not really know how to code well, probably you're going to be a burden on the team.
Yeah.
So I believe there is some minimum requirement for coding, that's for sure.
So no bare minimum coding that is there for a company. Have the passion for your field that you're applying for, and just be a learner forever. Be willing to learn.
Exactly.
Yeah. Okay. And on the learner note, you are a learner. Like you are in university right now, you are doing your master's, but you're doing your master's in electrical engineering. Your passion, however, is machine learning engineering. So how do you stay up to trends with the latest trends in the industry?
Okay, so electrical engineering, luckily, is a very broad field. It has so many like subfields. One of them is basically machine learning. So I'm also like trying to take advanced courses in machine learning as well from the electrical engineering department. But I'm mainly interested in the application of artificial intelligence in electrical engineering. So to keep myself updated as much as possible, I like to attend conferences at least online.
Okay.
So when there are conferences, usually researchers from both universities and industries try to publish their state-of-the-art and latest research, and they present it. So basically, you save a lot of time researching for what's the latest, because in order to have a paper that would be accepted in a well-reputed conference, it has to have some contribution on the field. So you don't search in the conference, everything is right there when it comes to state of the art. Also, the authors will present the paper, so you will hear about the paper from the authors themselves. So this will will help you a lot in catching up with what's happening lately in the field.
Got it. Got it. And I will just wrap up this interview, but before that, I'll ask one last question to you. 5-6 years back, when you were still doing your bachelor's, what was the one thing you wished you knew about data science before you actually ventured into it?
My main concern about data science currently is the false advertisement about it. So you can see a lot of courses on the internet or from actually accredited universities that become a data scientist in 3 months, or become a coder in 6 weeks, or become software engineer in like 6 months, or like this kind of advertisements. And these courses are really smart, very intelligently designed. So you will have some simple projects that you can do, and you will do them very fast. But to actually have something production worth that will have a practical value, you really need to spend years and work really hard in data science. It's just courses from the internet. Real world application is much different. Most of the projects that you will see on other sites that tries to teach you data science, most of the projects will be very simple. The data you will be given the data, you just get some lines of code from the internet and get it working. This is not real life. Real life is about acquiring the data, knowing what the business requirements is, a little bit of coding there, a little bit of data processing there, and you will have an iterative process that will end it will not end in less than a year probably. So yeah, that's that's what I should have known.
Yeah, that's really amazing to hear. And I love this conversation with you today, Muhy.
Likewise.
Thank you so much for doing with us today.
Thank you. Likewise. Thank you so much.
Thank you.